So I went ahead and I created another video that's demonstrating other ways to control the LCD contrast. In this case, I'm actually using what's called a digital potentiometer, and this digital potentiometer is made by microchip, and it basically has an interesting what's called an SPI interface, which means serial peripheral interface, if I'm not mistaken. Usually standard SPI has dedicated SDI and SDO lines. This one had an interesting interface, so it was more like a hybrid, like I2C/SPI interface, because the SDI and SDO line were on the same line. Internally inside the device, it's actually multiplexing when when an input and an output is occurring. As you can see here in the simulation, you can see that I have some dotted lines. Inside the test bench for the simulation, I have what's called a weak pull-up. So basically I'm reassigning the line to an H instead of a 1. The reason I'm doing that is so that way the simulation could show when when the pull-up was taking over, and then I could monitor when I was capturing that it was giving me it's kind of like an acknowledge, but in an SPI case where it's telling me that it confirmed what I was writing into the device. So I was monitoring that and making sure that it was coming up in the right location, and that's why I have that set up that way in the test bench. So similar to the other one that I showed in the previous video, it's just controlling the contrast of the LCD, but in this case you can see it's taking a lot longer. In the last video I was changing the contrast, and if you could see the timing, it was like 2 microseconds. In this case you can see the timing is like out in like the 150 microsecond range, and the reason for that is because instead of running parallel, we're running a serial. So let's take a look and see how well it works. So again, we're going to be making changes through the switches, and then I have again this button here for begin. What I went ahead and I did is I hooked up a multimeter so we could actually see the voltages coming through, and it's actually coming through right here. So you can see here's where the digital potentiometer is, right down here. There's no breakout board in this case, it's just a chip in the breadboard. So let's go ahead and make some changes, and you should be able to see here. I'll try to get them both put down so you can actually see the changes occurring. Alright, so there's the multimeter, there's the display. Alright, let's start playing with some of these switches and see what happens. So I just changed the switches and I'm about to hit begin. So you can see that the actual contrast changed, and you can see the voltage changed. So let's do it again. We went all the way down to 0, and you can see that we have full contrast on there. Let's bring it all the way up to 3.3 and let's see what it does. So basically what this digital potentiometer is doing is as I'm sending codes through the enhanced SPI interface, it's decoding these 8 bits that I'm sending, and what it's doing is it's adjusting where the wiper location is on the internal potentiometer. So let's go ahead and begin again, and we'll see it go to nothing on the display, and that brought the voltage all the way up to 3.3. So let's see if I can do this from afar so you can see a little better. So I'll put these switches all the way down again, and we'll go ahead and hit begin, and you should see the contrast. Contrast went all the way up again. And we'll do that again. We'll shut the contrast more or less off, so you can see the contrast is now off. Again, this was also very fun. Stay tuned for the next video. Thank you.